Today we're going to talk about Fama Macbeth regression. Fama Macbeth regression is a method used to estimate the parameters for asset pricing models, such as the capital asset pricing models, or CAPM. This method estimates the betas and risk premium for any risk factors that are expected to determine asset prices. So the method works with panel data, and the parameters are estimated in 2 steps. So let's take a look at the example here. Suppose we have n asset, which is I equals to 1 goes to n, and suppose our n equals to 17, means we have 17 different assets. It could be including, say, Coca-Cola, Facebook, or Google, and those are our assets to work with. Suppose that we're working with time t from the first period until the last period, and suppose we're working with 120 months of data. So that would be like 10 years of data. And then suppose we have 5 factors to work with. Those 5 factors are the Fama French 5 factors. And so let's see how we can work with this. So inference problems will likely arise in such cross-sectional regressions because the fundamental assumption of the classical linear regression may not hold. Potential violations include measurement error, covariance among the residues because of the heteroscedasticity and serial correlation and multi-collinearity. To address the inference problem causes correlation of the residues, Fama and Macbeth proposed a 2-step method to estimate the cross-sectional regression returns on risk factors. This 2-step regression is designed to estimate the premium rewarded for the exposure to a particular risk factors by the market. So what are those 2 steps? The first step is that we need to run n time series regression, one for each asset or portfolio. For example, we're having 17 here, then we need to run 17 times. How we're going to run it? We're going to run the excess return. For example, suppose this is the first asset. I'm going to have to run the excess return on the factor on the factors to get the factor loading. And I'm also having the residues. And for each asset, I'm having one factor loading for each asset. Then in the second stage, we need to run cross-sectional regression like t time, one for each time period. So we have like 120 time regression. And in this regression, we need to estimate the risk premium. In matrix form, that we will estimate the risk premium by regression, say at time t equals 1, we will have the return of the asset 1, the return of asset 2, until the return of asset like 17. And then here we're going to have, say, our estimated loadings for factor 1 for asset 1. Say this is beta estimated, and then until the 17 estimated. And then we're going to have a regression that what is the loading for this factor. And then we're going to have a time series estimation for this. So we're going to say for the first factor, we're going to have 120 observations. And then when we actually need to calculate the value, we'll just use the average of this 120 values. The importance of this regression is that it allows you to calculate the standard deviation of your estimation. Because if you're gonna take this lambda estimate as the average, actually it's t, 120 t, and sum up all your different period estimation, then you can use a formula to calculate the standard deviation of your estimates to generate the sample errors. In this case, your standard deviation would be sigma square equals to t square, and sum up at all the time period t. In our case, it will be 120, and minus your estimation and square. So that's it about Fama Macbeth regression. Thank you. To do a little bit of summary about Fama Macbeth regression, let's just say the steps. First, that you need to run the time series regression to get the beta on the factors. That, for example, for each asset, that you need to run the time series regression to estimate, say, your factors, and you need to get the betas. The second is run a cross-sectional regression at each time period. At each time period, you have n asset, then you need to run it on your estimation of beta for, then for each asset. Then you can get a, say, lambda estimation. Then you can estimate your lambda or the alpha as the average across the time. So lambda will be an average across the time, and alpha also will be an average across the time. And then you will be able to calculate the standard errors using the formula, because now you have time series data. So this is actually very important. This is the main point. The standard errors are easy to calculate, like for your factor risk premium. Then you can run the test. Run the test about the distributions, and so. There's a fact is that Fama Macbeth, the regression actually corrects for a correlated assets across time. It's a panel regression with clustering. The Fama Macbeth regression does not correct for generated betas. And there's another fact is that Fama Macbeth regression assumes errors are outcorrelated over time. It's very easy to add correlation over time though. That's it. Thank you.